have you done any sums, any questions in the chapter?
No, sir.
I observed some some books related to SAT maths. In that book, there are some chapters, circles. Yeah, actually, you told one. You told me about one question. That's about find the center and radius of circle.
Yes.
In the previous exam.
After my SAT? Yes.
Yes. SAT exam?
Yes, sir.
Yes. Yeah, particularly many books shows the chapter circles.
Yes, sir. I'm gonna start my practice in the book by tomorrow morning. Yes, sir. I'll start it from tomorrow morning. So I'll go by chapter wise in the book that you gave it to me.
Yeah, that book, Prep 2024.
Yes, I'll start it from tomorrow morning. I'll start it from tomorrow.
Okay. Do you have Kindle app downloaded?
Kindle app downloaded? Yes, I was about to ask you for that.
Yeah.
I'll see if this can support the Kindle app.
Yeah. Your device easily support it. I think you need to install Kindle app.
Yes, I'm doing it right now. 1 second.
If it is a laptop, there is software. Otherwise,
I was about to download in this and log in, but then you remember how you got the OTP, sir? The other day, I was logging in.
Okay. For purchasing or something like this, we got to OTT just to purchase that book,
yes,
but not access to get access that book. It's not to get access that book. It is just to purchase that book.
Oh, can I share my screen? Can I share my screen, sir, so I can just log in my iPad?
Yeah, OTT is not required to install Kindle Edition.
I forgot the password and the username. I'm like for your email.
Yeah, for the password only. Whenever necessary, you can send me message. You can just ring me anytime.
So you can say it. I'll write it down so I can log in.
Yeah. What OTT?
No, sir. The your email and the password.
Yeah. Do you remember?
I don't remember, sir. Something D.
You used it at that time, but it was already
is it
saved in that device.
Yes, sir. But I'm logging in my iPad. So
okay. Yeah. I got it now. You want to log in through another device?
Yes.
I think to read the book, I suggest tab. Tab is more convenient.
In that only. Yeah, in that only.
Yeah, right. Okay, let's do it. Anytime. You can do it anytime. Yeah,
if you just send, can you text me the email and user, sir? So I'll just log in.
Through WhatsApp,
Yes, sir. Because I got my app just now. I just installed it.
Yeah, sure. For reading that book, Kindle books, tab is preferable, more convenient than laptop.
Yes, I don't use laptop.
In Kindle Edition, there is multiple facilities are there. If you highlight one word or one sentence, it will show the meaning of that word, and it also suggests to search in web also.
Oh, that's cool.
Yes. I'll show it right now. See, these are the questions collected from some JEE main, like their books. Yeah, these questions are, if you practice this type of questions, you will easily understand SAT questions.
Yes.
These questions have how more difficult levels. Difficult levels, these questions are high.
Yeah.
So then it will be very easy to understand SAT questions.
Yes, sir.
Yeah, don't confuse it. It is not a lecturer. It is a lecture hall.
Lecture hall.
Yeah, in the previous questions we did. It is lecturer, but it is a lecture hall. The classroom.
Tab 5 was to a lecture hall. The number of ways that a student.
There are 5 doors to a classroom. The number of ways that a student can enter the hall and leave it by a different door. That means.
So can we do it in this way? 5 factorial by 1 factorial, 2 factorial, 3 factorial, 4 and 5.
Door 1, door 2, door 3, door 4, door 5, right?
Yes, sir.
He can enter. See a different door. It is very important point. He can enter D1 and leave by D2. It is
Yes,
one way. He can enter by D1 and leave by D3.
Yes, sir.
D1, D4. D1, D5. Okay. Next, he may enter through D2 and leave from D1. D3, D1.
Oh, it can be 5 times 4, 20, no, sir.
See, it is manual work, manual solution.
Okay.
Now,
D2,
okay. Next,
D1,
these are 8 ways. Now, D2, D1. It's already over. D2, D1 is over. D2, D3. D2, D4. D2, D5. That's it. Okay. D2, D1 is already over. Now, D3, D2. D4, D2. D5, D2. Next, D2, D3. D3, D1 over. D3, D2 over. D3, D3 not possible. D3, D4. D3, D5. Next, D4, D3. D5, D3. Next, D3. D4, D4, D1 over. Yeah, D4, D1 over. D4, D2 over.
D1.
D4, D2 over. Next, D4, D3 over. D4, D4 not possible. D4, D5.
Yes.
D5, D4. Count them.
1, 2, 3, 4.
8.
4, 8.
11. 11 plus 3, 14. 14 plus 2, 16.
20, sir.
How much?
20.
20. Yeah. It is the practical calculation. Okay. But see, there are 5 things. There are 5 things. Okay. There are 2 places, entry and leave. Okay. 5 things are arranged in 2 places.
Yes, sir.
Number of ways of arranging 5 things in 2 places, that is 5p2. See, number of ways of arranging 5 things in 2 places. Please tell the number of ways of arranging in n things in r places, that is NPR. Number of ways of arranging n things in r places is NPR.
Yes.
What is formula for NPR? Do you remember?
N factorial by n minus.
Yeah, n factorial by n minus r whole factorial, right?
Yes, sir.
So what is the value of 5p2?
5 factorial by
5
5 minus
factorial by
3 factorial.
5 minus 2 whole factorial, right?
Yes.
5 factorial by 5 minus 2 whole factorial is 3 factorial. How to write 5 factorial? It is
5 times 4
5 times
times 3
4
factorial.
times
3 factorial.
You can stop anywhere and write factorial there.
By 3 factorial.
By 3 factorial. What happens now? 3 factorial, 3 factorial get cancels. 5 fours are 20.
20.
These are 20 ways. But it is manual, that is practical. It is theoretical, right? So keep this point in your mind that number of ways of arranging n things in r places, that is NPR, its formula. N factorial by n minus r whole factorial, right?
Yes.
Got it. Now, option?
Option 1, sir. 20.
That's good. Option 1. Have you visited Hyderabad?
Sir?
Have you visited Hyderabad and Tirupati?
Oh, I stayed in Hyderabad.
Okay.
Oh, when I got there, yeah, I visited Hyderabad. I visited Tirupati. Yeah.
Tirupati?
Yes, sir.
Temple, yeah. 15 bus fly between Hyderabad and Tirupati. The number of ways can a man go to Tirupati from Hyderabad by a bus and return by a different bus? Okay. Yeah, there are how many buses?
15 buses.
Let those 15 buses be B1, B2, B3, B1, B2, B3. So on.
B15.
Tell one option, not option. Tell one way.
Oh, B4.
Go to Tirupati and return from another bus. Yeah, you may go through which bus?
B4.
Yeah, B4. You may go through B4 and return not through B4. Some other.
Yeah, B2.
B2, right. B4, B2. Okay. In this way, two numbers are arranged. Okay. Out of 15 numbers, previously we did one calculation. That's about 5 things, 2 places. 5 things are arranged in 2 places. 5 things are arranged in 2 places. So we can do one thing practically. That means 2 columns. For example, two blanks. We need to fill these blanks. We need to fill these 2 blanks with 2 different numbers from these 5 things. 5 things, 2 places.
Yes, sir.
Yeah. Number of ways, 5 things, 2 places.
5 things, 2 places.
15 things. Previously it was 5 things, 2 places. Now it is 15 things, 2 places. Do you remember that formula?
NPR.
Yes. So here it is
15P2.
Very good. It is 15P2. What's the value of 15P2?
15 factorial.
Very good.
By 15 minus 2, 13 factorial.
How to find its value?
15 times 14 times 13 factorial by 13 factorial. Also.
Now?
210, sir.
That's good. Answer is 15 times
Option
14.
15 times 14, 210.
Equal to 10. Got it?
Yes, sir.
Option 3.
Yes, sir.
Can we clear? Can we clear right now? At this stage?
Right now? Yeah. Yes, sir.
Okay, right. Now, there are 50 stations on a railway line. The number of different kind of single single second class. There is no significance for second class. Don't use second in the calculation. We need not use second in the calculation. There is no significance for second class, third class, AC, non-AC, like that. Just we need tickets only. We need to calculate the number of required tickets.
Yes.
See, we need not bother about second class or third class, no matter. Right. There are 50 stations on a railway line. The number of different kinds of tickets must be printed so as to enable a passenger to travel from one station to another station. That means this is station 1, this is station 2, this is station 3, so on. 50 stations are there. Yes, 50. So the question is, at this counter, how many kind of tickets must be available? At this counter, the person, how many different kind of tickets must be prepared? Yes. Any passenger would ask for, please give me ticket for station 1?
No, sir.
No. So persons may ask for the ticket for station 2, station 3, station 4, so on up to station 50. No one asks. Suppose if you are in a Rajahmundry railway station, can we ask that counter, please give me one ticket for a Rajahmundry station? No, because that person is already in that station. Okay, so tickets for Rajahmundry station need not be at that counter. Similarly, at the station 1, ticket for station 1 is not necessary.
Yes.
Ticket for station 2 must be there. Ticket for station 3, so on, ticket for station 50. So how many different kind of tickets must be there with station 1?
49.
Very good. At S1, there must be 49 different kind of tickets must be available. At station 2?
49.
Very good. And station 3?
49.
So on, station 50, there should be 49 kind of
49.
tickets available, right?
Yes, sir.
Multiply them. No, sorry, add, not multiply. So authorities should print 49 different kind of tickets for station 1, 14 different kind of tickets for station 2, so on. 49 different kind of tickets for station 49. Can you say 49 plus 49 plus 49 plus so on? How many times? How many stations are there?
50.
Yes. Please tell its value. Sorry, not last also 49.
40.
50 terms.
Yes, sir. Option 3.
Are you sure?
50 times 49.
How did you do it?
50 times 49, sir.
Calculator?
No, sir. I just did 50 times 49.
Okay. 50 times 49. 50 times 49.
That's 0, 45, 0, and 20.
0, 20, 24, 24. 245 is right.
Okay. Sorry, you got the answer.
But here also technically we can use the permutation concept, that is, out of 50 stations, 2 stations are arranging 50 things in 2 places. What is its formula?
50 times. Sorry.
50 factorial by
50 factorial by
factorial. How to write it?
50 times 49 times 48 by 48 factorial.
Yeah, into 48 times factorial. By 48 factorial, right?
2450.
Got it?
Yes, sir.
10 men and 6 women are to be seated in a row so that, do you know what is EAM 2013?
MSET 2013?
Yes, right. 10 men and 6 women are to be seated in a row so that no two women sit together the number of ways they can be seated. What's the condition? What is this condition? No two women sit together. Women are not allowed sit side by side. Women must be sit beside a man. Okay, it is a process. That's it. It is it is a question. See, 10 men, 6 women to be seated in a row so that no two women sit together, right? So there is one trick. There is one trick. Let us do some calculations, right?
Isn't 16
Yeah. Yeah. Do you
P2?
know? Yeah, we need some detailed explanation for it. I'll explain it for it. Choose three numbers or three terms, three letters or something. XYZ, for example, let us take XYZ. Arrange XYZ in a row.
XYZ.
XY. First seat. There are two seats.
Okay, XY.
XY, YX.
YX.
XZ.
XZ.
Yeah,
Z.
XG, ZX. YZ, ZY.
Z.
Total number of ways?
6, sir.
Yes. Because three things in two places. Three things in two places. That is 3P2.
Yes, sir.
3 factorial by 1 factorial.
1 factorial.
1 factorial is 1, you know. Yeah, yesterday, bad luck is yesterday's class was not recorded. Actually, I wished to cut the part of what is 0 factorial.
Right. But you have it from my class, sir.
Unfortunately, to finish the recording.
You have it from my class the 2 days ago, no, sir.
What? Tell again, today's?
2 days ago, you have the same recording of 0 factorial, no, sir. When you were teaching me.
No. At that time, I told you I will explain the reason detail later.
Oh, right.
But it was not recorded. Yeah, I thought to create a clip for that part. Yeah, let's do it today. It's very important and very useful and a very thought-provoking concept. See, yeah, a cloud space is cloud is cloud of Zoom cloud. Zoom cloud is filled, no space in cloud. Zoom cloud especially, it provides it some space. My friend, another lecturer is also using my account to teach his student. Yeah, so let's do it again today. But it must not be artificial. It must be natural. That clip, okay. You see, yeah. Answer is 3 factor means 6.
Yes, sir.
That's why these are right. Now let us take one condition. Okay. Now arrange 3 things in a row. Can you say how many ways? 3 places, 3 things. That is 3P3.
3P3.
It is 3 factorial by
3 factorial 1, sir.
0 factorial. 3 minus 2.
Oh, right. Yes.
Yeah, NPR means n factorial by n minus r factorial.
Yes, sir.
Now tell. That's why 3 factorial by 3 minus 3 whole factor. What's the value of 3 minus 3 whole factorial?
3, sir. Sorry, 6, sir.
The 0 factorial, right?
Yes, sir.
What's the value of 0 factorial?
1.
Yes. So it is 3 factorial. 3 factorial value 6 only. Okay, right? So there are six arrangements to arrange 6 things. That those 6 things are XYZ, XZY, YXZ,
Y,
YZX, ZXY,
ZYX.
ZYX. For example, there are two particular persons that are X and Z. X and Z are X and Z. For example, X and Z have no talks. That means they don't want to sit side by side. We are arranging a party for three persons. We need to arrange three persons to sit in a row. In that process, X and Z rejects to sit side by side. So what arrangements are taken off, eliminated here? X and Z.
The third option, sir.
First, second option also not allowed.
Oh yes, sir. Second.
So
third.
We need not use the second arrangement. It is taken off, and this
Even,
also.
Yes, sir.
And this also.
Yeah.
The remaining arrangements are 1, 2, 3 only.
So even the fourth one, sir.
Fourth one, 1, 2, 3, fourth one. Yes. This also taken off. The remaining arrangements are only 2.
2, sir.
How to do it manually? Since these are only 3 persons, it can be done manually, practically. But it is 30 things or 13 things we cannot do in this way. We cannot do find answer this way. Okay. So
no,
we need a theoretical procedure to find the result, right? See, now the procedure is X and Z are refuse. X and Z don't want to sit side by side. Okay. In that case, Y has no restriction.
Yes, sir.
So first arrange Y. Arrange Y. How many places are there for Y? This is one place and this is one place. This is one place. There are two places. There are two places for X and Z to sit so that X and Z are not side by side. Got it?
Yes. Yes.
Yeah, see, two things. Two things, two places. Two things, two places. Number of ways of arranging two things in two places, 2p2. 2pt value, 2 factorial by 0 factorial. What's the value of 2 factorial? 2 only.
2.
That's another question. For example, A, B, C, D, 4 persons are there. These 4 persons are to be arranged in a row. But B and D don't want to sit side by side. The total number of arrangements are 24. The total number of arrangements are 24. Okay, it is difficult to write all the 24 arrangements. So let us do it manually. Let's do it theoretically, not manually, theoretically, right? So yes, we need to arrange 4 things in 4 places. So do you remember 4 things in 4 places? Number of ways are 4p4. 4p4 means 4 factorial by 0 factorial. That is 4 factorial. The value of 4 factorial is 24.
24.
So number of ways of arranging 4 persons in a row, 24 ways. Among these 24 ways, some options, some arrangements are taken off. Some arrangements are eliminated, right? Some arrangements are not used. So let us see. What's the condition here? B and D don't want to sit side by side, right? So first arrange these 2 persons only. But because there is no restriction for AC. Those 2 conditions are, those 2 persons are AC and CA. We are arranging just remaining two persons in a row, AC and CA, only 2 ways, right? Yes, of arranging these 2 persons in a row, we can see there are 2 gaps between them. This is 1 gap, this is another 3 gaps. We can find 3 gaps between them. In these 3 gaps, we can arrange B and D. Tell one chance. B
and D.
That means this arrangement is BADC. And tell another chance.
D and B.
D and B. This is DA, BC. Okay, and we can do this way also. Here B, here D. Then this means A, B, C, D. Right?
We can do A, D, C, B. Oh, is it there?
Yeah. So in these three places, two things are arranged. Two things are arranged in these three places. These are 3p2 ways.
Yes, sir.
Three places, two things. Three places, two things. That is 3p2. That is 3 factorial by 1 factorial, 6 ways. So like that, we can write 6 options, 6 arrangements. We wrote just 3 arrangements. Of course, BD and DB also there. So in this way, there are 6 arrangements. 3 places, two things. Okay. Now, number of ways of arranging A and C in a row? 2. AC and CA.
Yes.
There we can see 6 arrangements. Arranging 3, filling 3 places with 2 persons. 2 persons can be filled in these 3 places, right?
Yes, sir.
For AC it is 6. For CA also it is 6. So the total number of arrangements are 6 plus 6, 12. Out of 24, the total number of arrangements are 24. Okay, to follow that condition, to follow the condition B and D should not be side by side. That the required number of arrangements are 12 only, because 6 plus 6 arrangements are taken off. Okay, let me tell it clearly. Now it is not possible to remove.
Oh, once you get off,
I got it. We need a blank. That means once the window is minimized, it is not possible.
When you go out of Zoom, I think so. Sir.
Not we. If we go out of PowerPoint, it is not.
Yeah.
See, the question is A, B, C, D are arranged in a row. A, B, C, D are arranged in a row. The condition is B and D should not be side by side. So first take those two things out of the list, from the list. If we take off those conditioned things in the list, we left with two things only. First, arrange these two things in two places that are 2 factorial. In 2 factorial ways, we can arrange A and C in a row. After arranging A and C, we can find three gaps between them, 3 places between them, 3 places between them, so as to fill those 3 places by those two things. So number of ways of arranging the remaining things is 2 factorial. See, whenever number of things, number of places are equal, the answer is n factorial. Number of ways of arranging n things in n row, n places, that is npn, that is equal to n factorial. Number of ways of arranging n things in n places, that is n factorial. So the remaining two persons can be arranged in a row that are 2 factorial ways. After arranging A and C, we can find 3 gaps between them. For B and D, 3 places, 2 things, that is 3p2. So the answer is 2 factorial into 3p2. Just now let us find a formula to this kind of questions. See, there are n things. Number of ways of arranging. There are n things. Okay, there are n things. In among n things, our persons don't want to sit side by side. Number of ways of arranging n things in a row, that is n factorial. After no. N minus r. First, we have to take off r things from n things. As we did B, as we separated B and D from A, B, C, D. So these r things should be separated from n things. The remaining things are n minus r. These n minus r things should be arranged first. These are n minus r factorial. Number of ways of arranging particular things in a row, that is that factorial only. So then there will be how many gaps? For AC, we can find 3 gaps between them. For PQR, how many gaps are there? 1, 2, 3, 4. 4 gaps. For LMN, LM, LMN, P, Q. For 5 things, how many gaps are there? 1, 2, 3,
2,
4,
3,
5,
4,
6. 6
5,
gaps for
6.
5 things. Okay. For n minus r things, how many gaps will be there? 2, 3 gaps. 3 things, 4 gaps. 5 things, 6 gaps. 1, 2, 3, 4, 5, 6.
Yes, sir.
5 things, 6 gaps. So n minus r things?
1.
N minus r things? Number of gaps?
1, sir.
N minus r things. Suppose if n minus r is 10, there must be 11 gaps.
Oh, yes, a plus 1. Yeah, got it.
Yes, plus 1. So there will be n minus r plus 1 gaps. N minus r plus 1 gaps between them.
Yes.
In n minus r plus 1 gaps, r things should be arranged. Number of ways of arranging these r things in n minus r plus 1 gaps is n minus r plus 1, n minus r plus 1, p r. These r things are arranged in these n minus r plus 1 gaps. So the final answer is n minus r whole factorial into n minus r plus 1 PR. Now, yeah, see, you need not remember that formula, but you can do it manually. See, now, total number of persons?
16, sir.
Yeah, 16 persons. Let's think in this way. 16 persons are there. In these 16 persons, 6 persons don't want to sit side by side.
Yes, sir.
So the remaining persons are
10, sir.
Yeah. First, let us arrange these 10 persons in a row. Number of ways of arranging 10 things in a row. 10 factorial.
10 factorial. Yes, sir.
Then how many gaps must be there?
11.
11 gaps. In those 11 gaps, 6 persons are to be arranged.
Yes,
These
sir.
6 persons are arranged in those 11 gaps. 11 places 6 things. Number of ways?
6. Sorry, 11.
11 things, 6 places. The number of ways are 11p?
6, sir.
Yes. It is equal 10 factorial into 11
10
formula?
into
11
factorial by
okay.
6 factorial.
11
Sorry,
minus
11 minus 6, 5 factorial.
Yes. Option?
11. Oh, option 4, sir.
Yes, very good. See, let's repeat again. 16 things are to be arranged in a row so that 6 things are, should not be side by side.
Yes, sir.
So, if we separate from these 16 things, we left with 10 things. These 10 things are arranged in a row in 10 factorial ways. Then there must be 11 gaps, 11 places for the remaining 6 places to obey that condition. So 11 places 6 things, 11 P6. That's the answer. Got it? We can see some more questions in this model.
Okay.
Yeah, it's very different question, puzzle type question. Can you ask it without the knowledge of permutations? We can do this question answer. Of course, the number is a little bit big.
9 are to be placed in
9 balls are to be placed in 9 boxes. I thought to show it practically, but I forgot to bring box, arrange boxes. Okay, we can do it practically. Of course, later. Can you play with crackers? That means on Diwali day?
Not like a huge crackers burst and all that.
Neighbors may feel disturbance. Neighbors are Americans. Your neighbors?
My neighbors are Indians, but the one up are not Indians.
Then there will be no problem.
There will be a problem.
To burn crackers.
Oh, there'll be a problem. I can't get an entire pack of Diwali box bursts and all that.
Okay. The policeman.
You know that they do it with ones like the stick that they do.
Little. Okay.
It's like essence stick, and they do it.
Have you ever spent in India?
Yeah.
It's where throughout the night they burn crackers.
We play the crackers like 3 times in India every night, like 3 times continuously.
Okay. Right. Here, 9 balls are to be placed in 9 boxes. 9 balls, 9 boxes. Actually, if there is no condition, if there is no restriction, the total number of ways are 9 places, 9 things. Can you tell?
9p
Sorry, 9
9
things, 9 places,
9
9
c
factorial. That
9
is
c
9p9. That is 9p9.
9. So isn't it C? Because they don't have to be
No,
arranged.
just wait, just wait. Yeah, how could you tell?
Because they don't want them to be arranged. They just wanted it to be placed. So
How
it's
could you,
9.
how could you tell option C?
No. I said 9C9.
Okay. I
Just
thought
roll
you
the
answered option
answers.
C, A, B, C, D. Actually, option
Is
C
that
is
the
correct.
answer? Let's move on. It's fine.
Yeah. Actually, option C is correct option.
Oh, then let's move on, sir. I'm good at this.
Yeah. See, without conditions, 9 things, 9 places. That is 9p9. That is 9 factorial. Number of ways of arranging 9 things in 9 places, 9 factorial only. Okay, right? But there are some conditions. What are those conditions? 9 balls are to be placed in 9 boxes, and five of the balls, 5 of the balls cannot fit in 3 small boxes. Among these 9 balls, these 9 balls are like this. I illustrate this question as this: 5 balls cannot fit in 3 small boxes. So, these 9 balls are like this. These are 5 balls. That means these 5 balls are big balls. And total number of balls are 9. So these are 5, 6, 7, 8, 9. These are the 9 balls. Because it is mentioned 5 balls cannot fit in 3 small boxes, right? And now
Yes.
it's about boxes. See, boxes are like this. 3 small boxes out of 9 boxes. Total number of boxes 9. Out of 9 boxes, 3 boxes small boxes. And remaining 6 boxes are big boxes. Yeah, this is the situation, right?
Yes.
Number of ways. First, let's do one thing. Let us, yes, let us use let us fill these 5 balls in these six boxes. What's the idea? Idea is to fill 5 big balls in 6 boxes. There are, oh, sorry, 6 boxes. Yeah, there are 6 boxes. Out of 9 boxes, 3 boxes are small boxes. 6 boxes are big box. So first, let us fill these uh, 5 balls in these 6 boxes. Number of ways, can you tell? 6 things, 5 places. Sorry, 5 things, 6 places. 6 places, 5 things. Number of ways are
6.
6p5. 6
6
places, 5 things.
Yes, sir.
Its answer is 6 factorial by
6 factorial by 1 factorial.
1 factorial. Means
So it's
6
6
factorial.
factorial.
So the number of ways of arranging 5 big balls in 6 big boxes. Okay. For example, B1, B2, B3, B4, B5. Okay. There are 6 factors. 6 factor means 720.
Yes.
720 ways are there to fill these 5 balls in 6 big boxes, right?
Yes.
Out of these 720 ways, tell one way. What is there must be one box free, because these are only 5 balls. We are filling these 5 balls in 6 big boxes, right? Yeah, tell one arrangement. There must be one box free.
B2, B1.
Here B2 or here B2, here B2. Where is B2? First place?
Yes, sir.
Yeah, here it is B2. Okay, next.
B3.
B3.
B4.
B4.
B1.
Yes.
B5.
Yeah. In this case, in this arrangement, last box is empty.
Yes, sir.
In some other arrangement, second last but one ball is empty. In some other arrangement, fourth box may be empty.
Yes, sir.
Anyhow, among these 720 arrangements, one box must be empty.
Yes, sir.
Is it possible to fill that empty big box with small balls?
No, sir.
No. Can we fill green ball?
Yes, sir. Yes. Yeah, sorry.
Yes. Yeah, it is possible to fill big box with small ball.
Yes, sir.
But it's not possible to fill big ball in small box.
Small box.
Big
Yes,
ball,
sir.
small box, not possible.
Yes, sir.
But small ball, big ball, small ball, big box is possible.
Yes, sir.
So there are four balls. The remaining balls are four. These four balls are to be filled in these four boxes. There is no problem to fill small ball, to put small ball in big box. There's a problem to put big ball in small box. It may not fit. So now the problem is cleared. The problem is solved. Four balls, four boxes. These four balls can be filled in these four boxes. 3 plus 1, 4 boxes, right?
Yes.
Number of ways of arranging four things in 4 places. 4 things, 4 places. Number of things, number of places are equal. So number of ways to fill 4 things in 4 places.
4
before is
4 factorial.
Yes, it is 4 factorial.
Yes,
Now
that's 20.
the total number of ways are using counting principle. I explained in the beginning class. A thing can be done in m ways, another thing can be done in n ways. Then the total number of ways to perform those things consequently. Mn, counting principle. The first task can be filled in 6 factorial ways. The first task can be done in 6 factorial ways. The second task can be done in 4 factorial ways. The total number of ways are 6 factorial into 4 factorial. Now tell its answer.
Wait, so will it give the answer?
Yeah.
For the question? Then it's option C, sir.
Do it. 6 you know the value of 6 factorial.
It's 120, 720.
Yes, 720.
720 times 24.
Yeah.
6, then 28, 0, 4, 14, 0, 6, 8, 2, 12, 3, 14, 17, 20. Zero, 8, oh, 8, that's 28.
It is 70 times
8, 9, 10, 11. 7, 8, 9, 10. Wait, something's wrong with my calculation. 1 second. 720 times 24. 0, 8, 28, 0, 4, 14, 0, 8, 8, 12, 1, 4, 6, 7. Oh, yes, sir. 17 to 80. It's option C.
Yeah. Do you know how to multiply faster Vedic method, Vedic way?
No, sir. I just do it normally.
Don't worry. Got the answer?
Yes, sir. Option 3.
Option C, right. Actually, today is a holiday for me.
Oh, the Bandh, sir.
Bandh.
What are they protesting for, sir?
Yeah, actually, the fact is even me and no student and no lecturer know the reason for Bandh. But
No reason for Bandh?
yeah,
Oh.
it's holiday due to Bandh only. No one
Oh,
knows the reason for Bandh.
I'll,
The reason for this
I'll,
protest.
no, I'll introduce the same thing over here so I get a holiday.
There must be some clarification for the persons. We are conducting, we are protesting on that day Bandh for the so and so reason. So that the reason, the problem may be highlighted to the government or some to authorities. Then there is no use of protecting this way. That means the problem is not highlighted. Just Bandh.
No Bandh, nothing, just a Bandh.
Yes. Now, Bharat, you know, our country's name has been changed, modified.
Wait, they said they are going to change, no, sir. They already changed it?
India is no more. Name of this country is not India, now onwards.
Yeah, it's Bharat.
Only Bharat. Then what about the names in passport? It is to be modified.
They'll ask us to go to the passport and visa again.
Is it passport? I think
it will be India itself, sir, I guess.
India. Yeah, that name is to be changed.
I don't think they'll do the Bharat for the passports that immediately.
Yeah, not immediately.
Yeah.
But the next coming passports may be like that.
Yes.
Yeah, see.
The
different words that can be formed by using the letters of the word Bharat, so that these words will not contain B and H together. Similar model, same model. As you did ABCD, same question.
Six factorial times 7 factorial by 2 factorial.
First, we have to separate those restricted letters from it. We have to separate B and H from the list. Because B and H have conditions.
So 4 factorial times.
Yes, 4 factorial. 4 factorial into, after arranging these 4 things in a row, there must be 5 places.
5 factorial by 2 factorial.
There must be 5 places, 5 blanks, 5 gaps. In those 5 blanks, these two letters are to be arranged in those 5 gaps, right?
Yes.
Two things, 5 places.
So 5 factorial by 2.
5 P2. 5 things, 2 places. That is 5 P2. Right?
5. Yes.
4 things means A-R-A-T. First gap, second gap, third gap, fourth gap, fifth gap. There are 5 gaps.
Yes, sir.
5 gaps, 2 things. 5 gaps,
yes,
2 things. 5 P2. Okay, and when arranging A-R-A-T, we can see repeated letters are there. What are the repeated letters?
A and A.
Do you remember in the previous class, we use one concept to that arrangement by taking 2 factorial.
Yes.
Yes, because 2 letters are repeated. Okay. Yes. Now 4 factorial by 2 factorial into 5P2.
5 factorial by 3 factorial.
Yes, 5 factorial by 2 factorial. 5 factorial. No, not 2 factorial. 5 factorial by 5 minus 2 whole factorial.
3 factorial.
Yeah, you told 3 factorial. You told X correctly. Okay, right. Now do this calculation. Can you do it on the screen?
Yes. It equals 4 times 3 times 2 factorial times 5 times 4 times 3. That and that equals 12 times 20. 240. So is the option 240? Like answer
240. Yes, 240 is correct answer.
Option 3.
Option, yeah, answer 240 correct answer. Now, yeah, 240, right? 12 times 20, 240, right? That's good. The number of arrangements that can be made by using all the letters of the word matrix. So that the vowels may be in the even places. First, let us arrange vowels. What are the vowels there?
A, I.
Yeah, how 5 places. These are 5 places. First place, second place, third place, fourth place, fifth place. What are the even places now? Second place.
2.
How many letters?
4.
6 letters are there.
Yes, sir.
So second place, fourth place, sixth place.
Okay.
These are 3 even places. Okay.
Yes, sir.
What are the vowels here? A is vowel, I is vowel. First, let us fill these 2 vowels. 3 things, 2 places. 3 things, 2 places. Number of ways?
3p2.
Yes, 3p2. That is 3p2 value?
3 factorial.
3 factorial by 1 factorial. That is 3 factorial, right? Number of ways of arranging A and A first is 3 factorial. Okay. Then the remaining letters are M, T, R, X. No repeated words are, no repeated letters are there. So these are 4 letters, 4 things, 4 places. What are those 4 places? This is 1 place, this is 1 place, this is 1 place. But after filling A and I in the 3 even places, 1 place will be empty.
Yes, sir.
So these 3 dotted place and the leftover place, totally 4 places, 4 letters. 4 places, 4 things.
4p4.
4p4, its value?
4 factorial.
Yes. So the total number of ways are 3 factorial times 4 factorial.
Factorial.
Tell its answer.
144. Option 1.
Yeah, 144, correct answer. Right. So the answer is 144.
144.
That's good. Two persons entered a railway compartment in which 7 seats were vacant. Yeah, direct question. There is no twist in it. Just very straightforward question.
Oh, 7p.
Is seated. That means 7 things, 2 places.
7p2.
2 persons. Yeah, 7p2. Do it on the screen.
Oh, it's using NPR, that is 7 factorial by 5 factorial, that equals 7 times 6 times 5 factorial. option here, sir.
Yes, that's good. Now, there are 8 floors on a building, including the ground floor. If 4 persons enter the lift in the ground floor, the number of ways in which they get down the lift, if no 2 persons come out of the lift at the same floor. How many floors are there?
Here, sir.
How many floors are there?
8 floors.
8 floors. Yeah, if a person entered the lift in ground floor, for example, in 4th floor, if a person entered the lift in 4th floor, will he opt for 4th floor? Will he press the button 4?
No,
No.
sir.
He may press the button any other thing, any other button except 4.
Yes, sir.
He presses the button except 4. Any other button except 4, right? The same way, a 4 persons. Josna, can you answer this question? Josna, are you there?
Yes, sir.
Can you answer this question? Yeah, just ask your friends in the group. The class is going on. To join all. Send this message in group.
Okay, sir.
Yeah. Can you answer this question, Tanika? 4
Yes,
persons
sir.
entered the lift in the ground floor. At first, 4 persons are in the ground floor lift. In the lift, when the lift is at the ground floor.
So is it 7C4, sir?
Yes, that's it. Simple question.
But they said that if no 2 persons come out of
no
the
2 persons. That means 7 places. Sorry, 7 places, 4 things. 7 places, 4 things.
Yes, sir.
If 4 persons are, yes, that means, yeah, luckily there is no option for 8P4 or 8C4. 8P4 or 8C4 is not given in the options.
Yes.
Some student may opt for this because 8 floors, 4 persons, 8P4, but 8P4 is not correct because and from the ground floor no one opt for ground floor, G0. Okay, ground floor. So, except ground floor, there must be 7 floors. Okay, 7 places, 4 persons. Josna, are you getting me? 4 persons are in the lift when the lift is in the ground floor. So they have those 4 persons needs to be enter floors: first floor, second floor, third floor, first floor, second floor, third floor, fourth floor, fifth floor, sixth floor, seventh floor. These are 7 places. 7 places,
Yes.
4 things. 7 plus 4 things is 7P4.
Yes.
The answer is 7P4, right? The number of different ways that 3 distinct rings can be worn to 4 fingers with at most 1 ring in each of the fingers is 4 fingers. 4 fingers. How many rings? 3 rings. Josna, are you there? Josna, are you there?
Yes, sir.
Yeah. Have you sent the message?
Yes, sir.
Yes. Let's continue. 3 rings are there. This is ring 1, ring 2, ring 3. 3 rings are there and the 4 fingers. See, the condition is at most 1 ring in each finger. That means there should be no rings for a finger. Of course, we can put 3 rings in for 1 finger. It is not allowed. That means no finger should have more than 1 finger. Sorry, no finger should have more than 1 ring.
Ring.
Yeah. Can you tell 3 things, 4 places? These are 4 places, 3 things. Josna, can you tell number of ways of arranging 4 things in 3 places? Yeah, I'm telling you, permutations. It is permutations. N things are places. N things are places. Are n places are things. N places are things. The answer is same, NPR.
NPR.
Big number should be written in the place of n. This place is for big number, large number. Okay. N things R places is NPR. 4 things 3 places is
4PR.
very good. Sorry. 4PR. Josna, can you tell the value of 4PR? 4PR, not 4P3.
4P3.
Josna, please answer 4P3. NPR formula. I think you are sleepy, Josna.
No, sir.
Yeah, NPR formula n factorial by n minus r factorial. Do you remember?
Yes, sir.
So 4P3 value? 4 factorial by?
1 factorial.
Very good. What's the value of 4 factorial?
24, sir.
24. The answer is, no, we need not do this calculation.
Yeah.
Yeah, calculation is not necessary. Josna, mark the correct option. Josna, are you there? Mark the correct option. That's good. Yeah. Here, the number of phases of varying 6 different rings. See, rings are different. There is no such condition, which is in previous question. At most 1 ring for each finger. That condition is not there. It is not possible to tell that condition because 6 rings, 5 fingers. So there must be more than 1 ring for some fingers. Yes, and without condition, the number of phases of varying 6 different rings to 5 fingers. See, there are 6 different rings.
6P5, sir?
No. Condition is not there. If the condition is there, we should use 6P5. But here the condition is not there. So, for example, these are the 5 fingers. Right? Rings. R1, R2, R3, R4, R5, R6. Okay. First take ring 1. How many options for there? Ring 1 to where?
5.
Yes. This can be done in 5 ways. This ring can be done in 5 ways. But R2, same 5 ways. Because there is no condition. No ring should have more than 2 rings. Such condition is not there. So if we put the first R1 in first finger, you can put R2 also in first finger.
Yes.
Next for R3, how many options are there for R3?
5, sir.
5 only. Next 5. Next 5. Next 5. 5 into 5 into 5 into 5 into 5. Josna, what is the answer? 5 into 5 into 5 into 5 into 5 into 5. Answer?
5 to the power 3, sir.
No.
5 to the power 6, sir. Option 1.
6 rings are there. 6 rings are there. So the option is?
First option.
First option, right. Do you have free time today, Tanika, at 3:30? 3:30 to India. 3:30 to India is 4:30 for you? Or 5:40?
No, sir. No, sir. 3:30 in India will be 4 for me.
And last time you attended 3:30 class.
Oh, the time changed, sir.
The time changed?
Changed. Yes, sir.
From as winter starts.
Yes, sir.
Okay. What is your what is our waking time?
Me?
Yeah.
I wake up at 5:30 or something.
If you have some work at what?
If I have work, I have to wake up at 5 or something, sir. That I can do it.
Yeah.
Morning.
What is 5? What is 5? What is your 5 to us?
4:30, sir.
Yeah. So 4:30 or 5? 5 is convenient
Sir.
or 4:30 is convenient?
4:30, sir. If there's like 1 hour class, then it's 4:30, sir.
Yeah.
For you, 4:30 for you.
Yeah. Shall we have class at 4:30? Same on same
Tomorrow?
topic?
Yes, sir.
Because no holiday, no college for me today. So
Okay.
Josna, we will have class at 4:30 p.m.
Okay, sir.
Yeah, ask tell all your friends to attend this class. Classes,
Okay.
permutations and combinations, sir. Objective
Okay.
questions. Okay,
Yes,
we will discuss the concept also.
yes,
Yeah,
sir.
4:30 to 5 4:30 to 5:30 p.m. 4:30 p.m. to 5:30. Objective
Yes.
class on permutations, sir. On Diwali, we will have class on combinations.
On Diwali, sir?
Yeah,
Sure.
Diwali is luckily everyone thought that Diwali will fall on Sunday.
Oh, when is it, sir?
Government has decided to conduct to mark Diwali on Monday, coming Monday.
Okay.
So one student has joined. John C. Who is John C? Who is John C?
SLE 1, sir.
Who is John C? John C means, you know John C, Josna?
No, sir.
John C, who is John C?
SLE 1, sir.
SLE 1. Okay, very good, very good. Where do you sit?
Harshini వాళ్ళ వెనకాల bench, sir.
In the bench, Harshini's bench?
వెనకాల bench, sir.
Yeah, second bench. Good, good. Actually, yeah, go ahead. The number of permutations that can be made out of the letters of, yeah, please do attend Jansi regularly. Today also we will have class at 4:30 p.m. on permutations, okay? Don't miss and tell our friends to attend. Second bench means beside last year.
Yes, sir.
Sorry, behind last year.
Yes, sir.
Okay, good. Jansi, once read this question.
The number of permutations that can be made out of the letters of the word mathematics when no two vowels come together is?
Yes, means the number of permutations that can be made out of the letters of the word mathematics when two vowels come together. So the condition is vowels are not side by side. That means they do not come together, right? So in that process, in that calculations, we need to separate those vowels.
Aren't they already not coming together, sir?
Of course, see those in those arrangements. This is one arrangement.
Yes,
When
sir.
we rewriting, A may be there. At this stage, vowels are not come together. Vowels are not together. But
Yes.
in arrangements, shuffle, the letters may be shuffle. In that case, I started record. Yesterday, Josna, yesterday we discussed zero factorial.
Yes, sir.
Oh, why record? Unfortunately, now also I forgot to record. Okay, right. See, got the point. Of in the rearrangement of the letters in the mathematics, in many arrangements there should be vowels side by side, right? So what should we do now? Separate those vowels first. A, E, A, I. First separate them. How many vowels are there?
4, sir.
The remaining letters are?
Consonant. 1, 2, 3, 4,
1, 2,
5,
3, 4, 5.
7.
1, 2, 3, 4, 5, 6, 7.
7.
Yeah. 7 letters are arranged in a row. Josna, can you tell how many ways are there to arrange 7 things in a row? 7 factorial. By what are the repetitions and the remaining letters? M is repeated.
Factorial, sir.
T is repeated. M is repeated 2 times. So we should write 2 factorial here.
2 factorial into 2 times 3 factorial.
T is also repeated. That is 2 factorial, right?
Yes.
After arranging these 7 things in a row, after arranging these 7 things in a row, how many gaps are there for A, E, A, I? These are 7 things arranged in a row. So how many gaps are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 gaps to fill these 4 vowels. Students, 4 things, 8 places. 8 places, 4 things. Number of ways, John C. 8 places, 4 things. Number of ways to fill 8 things in 4 places.
8 factorial.
8p4. 8 things, 4 places, 8p4. 8 things, 4 places is 8p4. So now tell the answer completely. 7 factorial by 2 factorial, and 8p4 formula.
8 factorial. 8 factorial
8 factorial by
4 factorial. 4 factorial.
Yes. Now tell the answer. 8 factorial by 4 factorial, right? 8p4 by 2 factorial. Do you remember? By 2 factorial. Because A repeated.
Yes, sir.
2 factorial. So final answer is 7 factorial, 8 factorial by, yeah. What's the correct option?
1 6 30.
Option 1, not option 1. Yeah, we need to do calculations. That means, see, the number of permutations when all vowels, sorry, we did reversely. When all vowels come together, it is not, do not come together. Yeah, in this process, yeah, we did reverse opposite calculation. See, the correct calculation is all vowels come together. Separate vowels A, E, A, I. Pack these 4 vowels A, E, A, I. Pack these 4 vowels. Okay. Number of ways of arranging, packing these 4 vowels is 4 factorial by 2 factorial, because A appears 2 times, right? So packing of these 4 restricted vowels is 4 factorial by 2 factorial. Now, if we separate these 4 things, the remaining things are 7 things. Those are 7 units, and this is 1 unit only. 7 unit plus 1 unit is equal to 8 units.
Yes.
Number of ways of arranging these 8 units in a row, 8 factorial.
8 factorial.
By m 2 times, 2 to t 2 times, 8 factorial by into 2 factorial. Into these ways are 4 factorial by 2 factorial. Yeah. Can you tell now which option is correct? John C, can you tell which option is correct?
Oh, wait, sorry. Second. 8 factorial times 4 factorial by. So is it option B 2?
How can you say 8 factorial times 4 factorial by 2 factorial whole cube? Yes, option 2. Got it?
Yes.
Yeah. Can you ask this question? It is a very challenging question. What's the condition? Yeah, Josna wants to read this question.
The number of ways that all the letters of the word sword can be arranged such that no letters are goodbye.
No letter is in its original position. Okay. What does it mean? Rearrange. For example, if we are asked to rearrange the letters of the word SWOT, we can write like this: O S O S. Sorry, W S D R O. We arrange these 5 letters. Okay, no problem, Johnsona. See, but in this arrangement, R is in its original place. Now, tell one arrangement so that no letter is in its original place. All the letters are different places. Tell one option, Jansi and Tanika.
O S W R D.
O S W.
O D R.
Yeah. In this arrangement, no letter is in its original place. Jansi, tell one more example.
R
R
O
R O
S D W.
S D W, right? Please tell one more example following the condition.
W D
W D
R S O.
R S O. No letter is in it original condition. Okay. Yeah, this is task for you. Screenshot this question and answer this question.
Me.
Simple. Yeah, all of you. So it is not correct. Yeah, this is task for all of you. You can answer this question. Whenever you get a reasonable answer, valid answer, send the answer to me. The number of ways that all the letters of the word SWOT can be arranged such that no letter is in its original position. We have done three arrangements. We have observed three arrangements. Like that, how many arrangements must be there?
So can you get back to the question where it said the lifts, like the number of stations, the stations question?
Is it?
Yeah. Yes, sir. 1 second. Yes, sir. You can get to the original one.
Yeah. Take screenshot. Jansi and Josna, take screenshot of this question. Try. Yeah. Don't miss today's class. And Jansi, tell. Do you know Lasya?
Yes, sir.
Yeah. Tell Lasya to attend class at 4:30. Tell all our friends to attend class at 4:30. I will give the explanation, theory and questions in permutations.
Okay, sir.
So Tanika, it is not possible to answer this question at once.
Okay, sir.
Yeah, Jansi and Josna, Tanika, have you got screenshot of this question?
Yes, sir.
Josna, take screenshot. Jansi, take screenshot.
Yes, sir.
Yes, sir.
Yeah. I will tell answer for this question in the evening class.
Oh, yes, sir.
Don't miss this class. 4:30 is convenient to you?
Yes, sir.
Only today it's possible, not tomorrow.
Yes, sir.
Yeah, on holidays we will have 4:30 class, right?
Yes.
Okay.
Yes. Bye, students. See you in the
Bye,
evening.
sir.
4:30.
One doubt, sir.
Yeah, tell Jansi. Tell.
ముందు క్వశ్చన్ లో 2 factorial whole square ఉంది కదా సార్.
Even I had that thought. Yes, sir.
Which one?
Yeah. For this
Yes,
one,
sir.
it's 2 cube,
So,
no?
so option 2 is not correct. Option 2 is wrong.
Yes, sir.
Because it is 2 factorial whole cube. Got it?
Yeah.
Then the option is correct. Actually, the answer is 8 factorial times 4 factorial by 2 factorial whole cube is the correct answer, right? Where is 2 factorial whole cube? No option is there, right? But
Yes, sir.
one option is correct option. Yeah, one option is there. Correct option is there. Use your brain. See. If I write 8 factorial as 8 times 7 factorial, agree?
So it's option.
Can we write 8
okay.
factorial as 8 times 7 factorial?
Yes, sir.
Into 4 factorial? Yeah, agree. 8 factorial means 8 into 7 factorial.
Yes, sir.
Into 4 factorial whole by what is 2 factorial?
2, sir.
Yes, 2. That means 2 into 2 into 2 into 2. Any cancellation?
2 gets cancelled.
2
Oh,
times
yes, sir.
2 is 8.
Okay, so it's
The
7
answer-
factorial times. It's option 4.
Option 4. Very good, John C. Option 4 is correct. 7 factorial into 4 factorial. By mistake, it is second option is not correct. Okay, got it?
Yes, sir.
Yeah, good. And then why didn't you ask at that time, John C?
అంటే మీరు చెప్తున్నారు కదా అని తర్వాత అడుగుదామని ఆపాను.
Once on video, I don't know. To identify once, can you ask on video once? I'll see who is John C.
Yes, sir.
Okay, got it. Right. Okay, good. Have a nice day, John C and Josna, and good night, Tandika.
Oh, have
See,
good day,
John
sir.
C, Tandika is our student.
Yes, sir.
Meet Tandika. Tandika, John C is new student in this class. Okay.
Oh, hi, Nancy.
Good night, Tandika, and have a nice day, John C and Josna.
Sir, thank you.
Thank you, sir.
Bye, students.